In this video, we're going to build a full stack mean application, and we're going to do it from scratch and step by step. So our web application is going to be a simple diary where we can add entries, update and delete entries. And we're going to start by creating an Angular UI framework, and this is also going to use Bootstrap for the CSS. Then we're going to create our backend server using Node.js, and we're going to enhance that backend server using the Express.js middleware. And then lastly, we're going to create a MongoDB account, and this will allow us to persist our data by connecting the application with MongoDB. And I've also left some timestamps in the description down below to help you navigate this video. So let's dive into the video. So we're going to begin by creating our Angular app from the terminal with ng new my-diary. I will add Angular routing and CSS, and after this finishes installing, I will open the newly generated folder in VS Code. If we expand the source folder, we will see the index.html file, which loads the app-route, and the app folder, which also contains the main component with the landing page. I'm going to begin by clearing the app component HTML file so we can start our project from scratch. And looking at our design, we will have two main components to start. So we're going to have a header which contains the navigation and a diary component that contains the entries. I'm going to run ng-gc header and ng-gc diary to create both of these components. In the app component, I will add two tags to show the header component on top of the diary component. And if I run the application with ng-serve in the terminal, we can see it open on localhost 4200. I'm going to improve our styling on the project by using the Bootstrap framework. We will install this by stopping our application with Ctrl+C and by running npm install -- save bootstrap at 3. We can now see Bootstrap has been added into our node modules folder, and we can add this into our project in the Angular JSON file on line 30 within the styles array by pointing to the node modules, bootstrap, dist, css, and then the bootstrap min css file. Now back in the app component HTML file, I will add a div with the class container around our app to add the default margins and responsive behavior to our web page out of the box with Bootstrap. If I relaunch the app, we can see our components have slightly been centered. And next, what we're going to do is configure the routing behavior so we can access other components when we later create them. I will remove the app diary tag and add the router outlet. And the router outlet will display the components we desire as per the route we navigate to. Then in the app routing module, I will instruct the empty path to show the diary component. If we restart the app, we can see the diary component has been shown. Now we're going to improve our header component by using Bootstrap to show a nice title link to the home page and also some navigation links to the home and also the data entry. You can visit getbootstrap.com for the nav documentation to understand how you can customize the web page to have it exactly the way that you want it. But if I head into the header component HTML file, I will add a nav with class navbar default. And within there, I will add some branding with a div of navbar header and an anchor tag of class navbar brand. And I'm just going to add some text to that anchor tag of my diary. And lastly, outside the navbar header, I will create an unordered list of class navbar-nav with two list items within an anchor tag of home and also diary entry. If we head back to our app, we can already see it looking a bit better. Okay, let's modify the diary component to show a table of entries. So first I will add a header of h2 tag with welcome to the diary. And below that, I'm going to create a table with the table tag, and I will use the Bootstrap CSS of table-bordered to add spacing and bordering to our table. I will use the thead tag to capture the headings of the table, and I will add a row with tr followed by the headings of date, entry and actioned with the th tags. So th will stand for table heading. And below I will add tbody for the table body, followed by 2 rows with the table data. So I'm going to have tr for table row, and then within those table rows I'm going to add td for table data, and I'm going to populate that with some demo data. At the end I'm just going to put no action under the action column, which we will later populate when we want to edit or delete our entries. Now if we open our app, we can see how we would expect the app to appear, with the header across the top and a table just down below. The next step will be to define some data to auto-populate our table rather than manually entering it here like so. We're going to store our data for the table in a shared service, as we will later require other components of our application to also access the diary entries that we have stored on the app. For example, if we would like to edit an entry, we would need to pull in that data into a new component. Let's say that's called the edit component. So the data is required in more than one place within our application. So to begin, I will create a folder called shared within the app folder and define a model class that will store our diary entries. I'll create a file called diary-entry.model.ts and export a class called diary entry, and I will use the constructor parameters to define a public date and entry property, both of type string. I will also create a service in a new file called diary-data.component.ts with the name diary data service. I will annotate the class with @injectable, and then that will be provided in the root. So all components of our application now have access to this service. And I will define a new array called diary entries of type diary entry and initialize it with 2 entries. Back in the diary component, we will define an array of diary entry as an empty array and initialize it in the ng-on-init function. Just a small note, ensure you have strict property initialization set to false in the tsconfig file to ensure that this style of initialization compiles. I will inject the diary data service into the diary component constructor and assign diary entries as equal to the diary entries of the diary data service. Now within the diary HTML, I can now use the ng-for structural directive to loop over the diary entries that we have in the TypeScript file. In the first table row tag, I will use an asterisk followed by ng-for equals to let diary entry of diary entries, and this will allow us to loop over our array of diary entries. Our HTML table rows will now be repeated for every entry that we have in our array. I will use string interpolation to populate the first table data with diary.date and the second with diary.entry. I can remove the second table row and leave the action as no action for now. And now we can see this working as expected within our application. I can now test this, so if I head back into the diary data component, I can add a new entry and see it automatically reflected in our table back in our application, all thanks to this ng-for loop. In this next section, we're now going to update our action column in our table. So under the action column, I would like an option to either edit or delete an entry. So in the diary component HTML file, I will replace no action with 2 buttons, and I will use the class styling from Bootstrap to style the buttons. I will use button-light for the edit button and button-danger for the delete button. And also in the CSS file, I will style the buttons apart from each other with button, open curly brace, and then margin-left as 10 pixels. So this will make sure that the buttons are not sitting over each other when they're in the table. Now to begin deleting entries, I will add a click listener into the delete button. I will want to tell the component which array item that we want to delete. To extract the index of the array item, we can use let I equals index in the ng for loop and pass in I to the onDelete method. If I implement the method in the component and print the index value, we can now see 0, 1, and 2 being printed into the browser console. To actually delete the entry, we will create an onDelete method in the diary data service, passing in the index number. And within that function, we very simply perform a splice on the data entries array to remove the index of that item. So that involves doing this.diaryentries.splice index and then number 1. And back in the diary component, we will reassign the diary entries array with this.diaryentries equals this.diarydataservice.diaryentries. Now the method of deleting the diary entries, however, is not as effective as it could be. All components within the application will need to keep calling get on the diary entries from our diary data service every time that they're updated. We can instead use a subject, which is a specific type of observable that allows values to be casted out to multiple observers at the same time. So if the diary entries are used by other components, they can all receive the updated entries together without having to always reassign the values manually. So first I will define a new subject in the diary data service, and I will import the subject from the rxjs package. Back in the diary component, I will create a new subscription to that subject, which is also from the rxjs package. And then within the ng-on-init function, we will now subscribe to the diary data service subject with this.diaryentries_sub equals this.diarydataservice diary subject.subscribe. Now within this subscription, we will receive the entries as an array from the subscription, and we will assign this.diaryentries as those entries. So whenever the diary data service subject emits a new array for the diary entries, the diary component will receive that array and it will automatically update its array. I will implement the onDestroy lifestyle hook as well, so that we can unsubscribe from this subscription each time that the component is destroyed. So how do we actually emit an updated piece of data? So we do this by using the next keyword. In the diary data service, we can use this.diarysubject.next, open bracket, and then this.diaryentries. And this will emit the updated array once the diary entry has been deleted. Now all subscribers to the subject will receive the updated array in our application. Back in the diary component, we no longer need to reassign the diary entries after the delete, as the subscription we have within the ng-on-init function will automatically reassign the array every time that the next method has been called from the diary data service. If we head back into the app, we can now see the delete button working. Before we learn how to edit an entry, let's take a look at how we can add an entry, and for this we're going to be using the Reactive Forms approach from Angular. To begin creating our form to add new entries, I'll create a new component with ng-gc diary form. To display this form, I will register the component in the router module with the entry of data-entry, and I will allow us to navigate to this page from the header by adding a router link directive to the data entry button. I will also add a router link for the home button and the branding, so we can click our way back into the home page. If I restart the application, we can now see the router links working. Within the diary entry HTML file, I will add a row and a cold div to make it easier for us to modify this page in the future. And I will add a form tag within this. I'll be using the reactive form approach, where we will be synchronizing the input elements of our form with a form group object and extracting the values from that object when the form has been submitted. And we're going to see how this works very soon. To enable the Reactive Form directives, we will have to import the Reactive Forms module in the app module file. The Reactive Forms module is imported from the Angular Forms package. In the diary form ts file, I will create my form object called diary form as type form group. I will initialize this with an ng on init. Form group will represent our form, which will contain several inputs, represented by form controls. Within the form group constructor, I will use a curly brace to define our form controls. So each control has a key, and I will use date and a colon, followed by a form control that defines the default value of this field, and also any validators that we might have. There are many other ways that we can enhance our form controls, but just for now we're going to specify what the default value is and if we have any validators, and we're going to see the value this brings to our form in a moment. So we will just say that the validators is that this field has to be required for our form to be submitted, and I will do the same for the entry field of our form. We will come back to the default value. Back in the HTML file, I will annotate the form tag with form group directive as equal to the name of our form group in the component. So we're going to call this diary form. I will now create the form within a div with the form-group class for styling, and I will add two labels for the date and also for the entry, and two text inputs for these. I will use the form control class on both the entries for styling, and I will synchronize them back into the form group object with the form control name property. So this is going to link back into our keys that we have in our form group object. Outside the div, I will add a submit button with the button success class to make it green. And in the form tag, I will register the submission with the ng-submit event emitter to the onSubmit method. Now when we submit the form, we will want to update the diary entries in the diary data service, and then we will want to navigate back to the home page to show these new entries. For both of these steps, I will inject the diary data service and the router from the Angular router package into the diary form component through the constructor. I will create the onSubmit function and first console log our diary form, just so that we can see the object that we create when we submit our diary form. Now in the browser we can submit an entry with the date of 10th of June, and we're just going to put entry 4 as the entry, and we can hit submit. And then in the console we can see our submitted form. If we expand the value, we can now see the form date and entry. So we're going to now use these values within our component. So back in the component, I will create a new diary entry using the form by extracting the form.value.date and also the form.value.entry. I will pass this diary entry to the diary data service into a function called onAddDiaryEntry, and within that method we will simply push the new entry into the diary entries, and then we will broadcast our new diary entries array with the diary subject.next method. Now our home component will receive the updated entries with the new diary entry, and as it receives the new array of entries, it will populate the table automatically. Back in the diary form component, I will use this.router.navigate by URL, passing in an empty string to navigate back to the home page. We can now test this out by making an entry and hitting submit. We can now see the entry being added and us being taken back to the home page. One last change I'm going to make to the form is to disable the submit button if the form is invalid. The form is invalid if either field is empty, specified in our form control with these validators. We can do this by accessing the disabled directive and making it equal to the inverse of diary form.valid. This boolean is evaluated every time that we update our form to ensure all validation is passing. Now when either field is empty, the submit button will be disabled. To begin creating an edit option, I will add a click listener to the edit button. Our design for edit will involve first navigating to a new route called /edit, and then / the index number of our entry from our array. In the onEdit function, I will pass in the index number, and then in the diary component, we will inject the router and use it to navigate to this new route, constructed within an array. The first item will be the word edit, and the second will be the index ID. Now back in the router module, I will register the new pattern for /edit /:ID. The colon tells Angular that the ID is a parameter, and for this route we will load the diary form component. Now if we head back into our app and select edit, we will see the route as edit /0, and the form component is loaded. Now back in our diary form, it gets a little bit complicated because we're going to have two different behaviors. One will be for a new entry, where the form is going to be empty, and when we submit the form, we're just going to be adding into our diary entries. And the second where it is in edit mode, where the form is pre-populated, and when we submit the form, we're updating an existing entry. In the diary form, I will create a boolean called edit mode as false. But how do we know if we should be in edit mode? And we do this by accessing the route. We can access the current route by first injecting the activated route into the constructor, and then within the ng-on-init function, we will obtain the param map of the route and subscribe to it. The subscription will pass in the parameters that we have in our current route, where we can check if the map has the ID. The ID is the same name that we provide in the Angular router. And as we know, if the ID parameter is present, then we will be in edit mode. So we will set edit mode to true, otherwise we can set it as false. We're going to pre-populate the form by applying the date and content value of our diary entry property into the form. If the diary entry is undefined, we will leave the boxes as empty as we would otherwise see when we're adding a new entry. We will first populate the diary entry property with the diary data service. So I'm going to create a new method called getDiaryEntry that takes an index number and returns an entry. The method will very simply use return followed by the extract operator to extract all the values from an object so that we don't modify the original entry. And we will request this.diaryEntries and use the index number in squared brackets to return just that single entry. The diary entry instance will be used to populate the form when we're in edit mode. Just below this, I'm going to define a new string as param_id to show the ID of the entity, and I will assign it to the param map subscription, and I'm going to add a plus sign to the start to signal that it's a numerical value, and I'm going to add a bang operator at the end to remove the null check on this item. We will assign the diary entry by calling getDiaryEntry method. Now that we have a diary entry populated, we can bind its values into the HTML by using the default value from our form control, and this is where we're revisiting that first argument within our form control. I will make the default value is equal to the diary entry.date if we're in edit mode. Otherwise, we're just going to leave this as empty. And I'll do the same for the entry. Just a small note that it is important we add this subscription first in the ng-on-init function to ensure the diary form is updated after we evaluate what the activated route is. If we head back into the app, we can now test this by selecting Edit and seeing our form populated along with the updated route. The final piece of the puzzle involves submitting the updated entry. If I go back to the onSubmit method, I will surround the onAddDiaryEntry method with an if statement to check if it is in edit mode. And if it is, then we will call a new method in the diary data service to update the entry. I will pass in the param ID, which will be the index to update, and the entry. Then in the diary data service, I will access the diary entries followed by the index in squared brackets as the entry, and broadcast the change to the diary entry subject. If we test this out, we can see our form is now updating. Now let's take a look at our working application. I can add new entries and I am taken back to the home page after they have been submitted. I'm able to delete entries and I can also update existing ones. It's a pretty simple app so far, but we've covered many different Angular fundamentals with multiple components. We've used routing, centralized services, subscriptions, subjects, and also data binding to create and dynamically populate our components. This is really great work. Thank you so much for watching this video. Join me in the next video where we will begin to look at Node.js and Express.js for persisting our data in a backend as opposed to having it all presented in Angular. So before we begin creating our Node.js backend server, let's take a look at how the application will grow from a single page application into one with a separate front end and a backend service. At the moment, when we run ngserve in the terminal, we're launching a Node server that hosts our static single page application. When we navigate to different routes, the single page application will display different components as we define in our routing module by creating and destroying components. Data is provided centrally within the application through the diary data service. However, this has limitations in that it cannot be persisted and stored. The Node backend service will be responsible for managing our data, and we will later connect it to a MongoDB database for persistence in a later video. The Node backend service will provide data management support such as retrieving, updating, and logical processing of data, as well as possibly authentication in the future. Whereas the single page application will load different components from different routes, the backend service will register different paths, known as URIs, which stands for Uniform Resource Identifiers, to provide different data responses for. The backend service will provide what is known as a RESTful service. So REST stands for Representational State Transfer. The service works by registering available URI paths that can be accessed by the static web application, and in return it responds with the required data. So our service behaves in a stateless way, which means each request is completed in isolation and does not rely or depend on the completion of any other requests. It is performed as an atomic operation. So the requests we send to our REST service will also contain a HTTP method that indicates the desired action performed on the request. So typical methods include get, put, post, and delete for reading, updating, adding, and deleting data respectively. And as a result, we can customize our URIs to only accept specific method types. When the REST service responds to a GET request, we will provide data in a semi-structured JSON format. So JSON stands for JavaScript Object Notation and consists of a series of key value pairs that can also flow in a tree structure. So this response can then be mapped to values and read by the single page application. And for example, we have a person here with a name, age, and a height and a weight. So now that we understand how our backend service will be used, let's dive into creating our Node server. It's important to remember that our backend server is completely separate to our single page Angular application. To make that distinction, I'll create a new folder at the project root called backend. I've placed it here just for convenience, but it could actually be anywhere in your machine, this folder. And then within that folder, I'll create our Node service in a file called server.js. I will add a console log to the server.js file to print running. We're able to execute the Node server by running node and then dot/backend/server.js. And then in the terminal, we can see running is being printed. Now we will look at how we can turn our node file into a server by providing a data response to an incoming request. So to begin, we will need to acquire the HTTP package and all the methods that come out of the box within Node.js. And to do this, we will create a constant, and we're going to call that HTTP. And we will use the require keyword from Node to consume the HTTP modules into the constant. Now the HTTP package will provide us with methods to create our server. And next I will create the server into a new constant by calling the createServer method from the HTTP modules. This method will create our server that will accept incoming requests and provide the appropriate responses. The createServer method accepts an optional argument function that is executed every time our server receives a request. The argument, known as a request listener, will accept two arguments: a request object that holds the incoming request details, and a response object which is used for handling the response that is returned. I will use an ES6 function to capture the request and response and to handle them in a method body within curly braces. To test our server, I will use the response object and call the end method, which tells the server that the response is complete, and I will pass in the text of hello world. I will now assign the port for our host to be listened upon with server.listen 3000, and we can now run our node backend. And what you will notice in the terminal is that the node service has not ended, as it is currently listing on host 3000 for any incoming requests. And if we ever want to stop our node backend from running, we can just run Ctrl+C in our terminal. And if we head over to the browser on localhost 3000, what we are doing is effectively sending a request from our browser to our server, and we will see the response of hello world is being sent back into the browser. So we've successfully sent and received a response of data from our node backend. So to enhance this backend service, we will need to enhance our request listener to add better middleware to it. And this middleware will allow us to handle unique requests that are made, and in turn to respond with appropriate data responses. So in the next video, we will begin to expand our functionality of the backend service by using Express.js. Express.js will be used to register unique URIs to provide actual data to the user when they send requests to our server and to different paths. We will also connect our single page application to the backend server so we can begin to use and display the data in our web page. So I'll see you in the next video. We're going to enhance our backend node server with a middleware component built with Express.js. So Express.js makes it easier for us to register REST endpoints that our single page application can call to receive data responses. So from a high level, we're going to create an instance of an Express application with all the middleware components we require. We will later see what this looks like. Then we will export the Express app and import it into our node server to then use. So let's begin by installing Express.js, and we're going to do that by running npm install --save express. And then when that's finished downloading, in the backend folder, I'll create a new file called rest.js. Feel free to call this whatever you would like. And within that file, I'm going to import Express.js into a constant with the require express word. We can then create an Express application by creating a new constant called app, for example, and that is going to be equal to express and then open and close brackets. So the purpose of our Express app for now will be to handle the data from our single page application. The end goal for this video is to migrate our diary data service component, where we're fetching all of our diary entries into the Express app for now. So our single page application can handle data through the REST service we create in Express, and no longer within the single page application itself. This might seem like we're just passing the same behavior from one place to another, but the benefit we will later realize will be when we connect our Node server to a database and we no longer require the data to be stored and handled within the Node server. So we're kind of passing that data responsibility away from the single page application into Node, and then in 2 videos time we'll be migrating it all into MongoDB. So back in the REST.js file that will use Express.js, we're able to register different endpoints for our Node server to respond to. We do this by using the keyword of use, and that will take 3 arguments. It will first take the request and response object, which is just similar to the Node server, but then it will also take a 3rd argument, which is a next argument. So the middleware will register multiple use cases that define different paths, and these are different URIs that we can send our requests to receive different responses. And if a request satisfies multiple paths, we can use the next method to pass on the request to the next satisfying middleware use, and we're going to see how this might work. To return a response from the middleware, we can call the send method on the response object. So let's pass in a string of hello from Express just to demonstrate this. And to make this Express app available to our Node server, we will export the app by using module.exports equals app. And then if we go into the Node server, we can import the Express app by using constant of Express, and then that will equal require, and then we're just going to pass in the path of our relative Express app, which is on the rest.js file. So our Express app provides all the middleware required to replace our existing request listener. So we simply pass that into the server brackets. Now if we restart our Node backend and head to localhost 3000, we can see hello from Express printed into the web page. So to demonstrate how the next keyword works, I'll define a new use case in the Express app, and all we're going to do is console log hello, and then we're going to call next. So when we send a request to our middleware Express app, we can expect hello to be printed into the console, and then the response, hello from Express, will still be returned on the web page. And that's exactly what we can see. Now if I remove the next method call and restart the app, we can see our browser page is loading infinitely, and that's because it's entering this first middleware method. No response has been returned, and it's kind of stuck there because it doesn't know where to go from here. There's no next method that is being called, and that's what's causing our backend server to remain in limbo. We can begin to define unique resource identifiers that enable our backend service to respond to unique requests, and that is beyond this empty localhost 3000 path that we're currently using. To specify the path that we would like to register, we pass in a new argument in front of the 3-part argument of our use method. So within quotes, I will pass in the path as /diary-entries, and this is going to tell Express to only respond to the request if that is the exact path that it is sent for. So let's look at how we can take the method that returns all the diary posts from our diary data service and move them into the Express backend service. I'll first copy the array of data from the diary data service into the Express file under a new array called entries. To help us replicate the eventual database our Express app will connect to, I will just add an identifier field to each entry. I will add keys of ID, date, and entry to them, and change the date to use March, just so we can distinguish between the diary data service values, which all use January, and the backend server, which uses March. And lastly, I will update the diary model in the Angular application, and this will now use ID as a number. And I'm just going to correct the diary data service and the diary form component by simply passing in fake ID values, just so that it compiles. So IDs are used in databases to uniquely identify each row, but in our app, we're currently using the index of each item in the array to get that row. We will later see in later videos how this can be beneficial. So in the method body of our ES6 function, I will return a JSON response. To do this, I will use the inbuilt response.json method. The method accepts a comma-separated list of JSON objects within the curly braces. So I will pass in the key of diary entries in camel case and the value of entries from our file. So now within our JSON response, we'll have a key of diary entries, and the value for that key will be all of our entries. So if we restart our node server, we can head to localhost 3000, go to /diary-entries, and we can see that JSON data for our entries being returned to us as text. In our Angular single page application, we will want to update the current getEntries method from our diary data service to now send a HTTP request to our backend service. And Angular makes this really easy for us to do with its out-of-the-box methods from its HTTP library. So to get access to that HTTP library, I will first import the HTTP client module into the app module file, and that comes from the common /HTTP package from Angular. Next, I will inject the HTTP client into the constructor of the diary data service, and that will make it available for all of the methods within that service, which includes the getEntries method. And I will change the diary entries array that is instantiated in the diary data service to be an empty array. Then I will update the getEntries method that we have to make a HTTP GET request to the backend server. And just before I do that, let's take a look at what GET is. And GET is one of the HTTP methods we have previously mentioned and is used for returning data from a RESTful service. We also mentioned the put, post, and delete methods, all of which have respective responsibilities. So to do that, I will call this .http.get, and I'm going to pass in the URI that we have from our browser. This request returns a subscription that we can then subscribe to, where the response from our request will contain that JSON data we saw from our Node backend server. And then within brackets, I will call this .json data, and we can reassign the array of diary entries we have within our diary data service as equal to the JSON data .diary entries. So that .diary entries is going to point to the values of that key within our JSON response. We currently have a compile error on the JSON data .diary entries key, and this is because our Angular application doesn't actually know what that JSON data will contain. It doesn't know what keys we're expecting, it doesn't know what type of values that we're expecting. But we can tell Angular exactly what it contains using angled brackets just after the get method. I'll then open a curly brace to describe the data that is returned. So we will have a key of diary entries, and that will contain an array of diary entry objects. If we had other keys, such as a message, we could just append that using a comma, and then we could have something like message, and then that is of type string. So now our JSON data is able to access the diary entries key, and Angular knows it will return an array of diary entry objects. Lastly, I will broadcast the updated diary entries using the diary subject, passing in the diary entries. In the diary component file, we also have a compile error as the get diary entries is no longer returning an array. I will simply remove the assignment to remove that compile error. Okay, so back in our application, we can see there are no entries being returned. In the console, we can see that this is due to a CORS policy. So let's quickly discuss CORS. So CORS stands for Cross-Origin Resource Sharing. It is a policy we apply to our servers to specify who and what kind of requests can be sent to it. It's kind of a security mechanism to control the incoming traffic for the server. So as our single page application makes requests to our backend server, we will need to enable calls on the backend server to allow those requests to then be handled. So in the rest.js file, we will need to enrich the responses that we have with specific cause headers that enable our Angular front end to communicate with the backend. So before we start looking at how we're going to do that, maybe stop to have a think about how we can achieve this on your own. So earlier we mentioned that the Express app can run code before all of the requests, and that's because of this next method that is provided. So to do this, I'll create a new use for our middleware, and I'm not going to specify a path, so that means all the incoming requests to our Node backend are going to be calling this middleware method. Within that method, I will set the header for 3 cause policies, and these are access control allow origin, access control allow headers, and access control allow methods. Allow origin will tell the browser which domains the backend request is accessible to. We will pass the value of an asterisk in after a comma to specify all domains can send requests to be handled. When a request is sent from a domain, it will typically include headers to specify details of the request, and we will want to expand the default headers that are accepted on the backend service to include origin, x requested with, content type, and accept. It's a good idea to check out documentation on cause headers at developer.mozilla.org, for example, and these will provide details on what the headers mean and how they can be used. Lastly, the allow methods policy will specify what type of HTTP methods we will support, and for our application we will support get for getting all the data, post for adding data, put for updating data, and delete for removing data. I will also add in options, which is a request for information about the communication options available on the request or response identified by the request URI. This is particularly useful when requesting information about what allowed methods from the client when requesting a response from the backend server. And then lastly, below this, I'm going to call next to ensure all incoming requests to our Node backend server are handled appropriately within the server. I'll restart the server and navigate back to the application. So let's take a look at the application, and we can now see all the diary entries are returned. However, this request has come from a HTTP method call to the backend Express server and not from the static web page, and we can see all the dates as March. This has been a really big step towards creating our backend server, where we can now register URIs in the Express server, enriched with cause access, and where 2 servers are able to communicate the shared data between them. In the next video, we're going to continue to enhance the Express endpoints to allow us to add, update, and delete methods with HTTP requests. So far, we've built our application with Angular and have partly covered the data service it uses to obtain diary entries to a backend server built with Node and Express.js. But in this video, we're going to flesh out the functionality of our Express middleware to enable full functionality of data from the backend. So currently, if we delete an entry and navigate away and back to the home page, our entry will reappear. And we're also unable to save any updated entries or to add any new entries. This is because the application only uses one GET request from the backend to pull all the data. So let's begin to update our Express server so we can add, update, and delete all from that same array. So the diary data service adds entries by extracting the details from the form, creating a new diary entry, and pushing it to the array. We're going to change this by making a post request to the backend server. So a HTTP post method is used to send data to a server to create a resource, and in our case that would be a diary entry. Therefore, we will need to append our new diary entry details to the HTTP request when it is sent. So we'll start by updating the Express app to read the incoming HTTP request. I will register a new middleware with the app. However, instead of using the method use, I will replace this with .post. So we can customize this method to specify the HTTP method it responds to. Therefore, I will also update the diary entries method from use to .get. And our post request will need to read the diary entry that is passed in the body, so we will require help from a Node Express package called body parser to do that. We can install body parser with npm install -- save body - parser. Next, we will need to import the body parser modules into a constant called body parser with the require keyword, and then we will use the body parser as an additional middleware by passing in bodyparser.json to support us in reading any JSON data from our requests. Okay, so back in our post method, I will give the URI as /add-entry, and I will optimize our request listener slightly by only passing in the request and response as parameters. I will not use the next keyword as it's not actually required in that method. I'll then push a new diary entry to the diary entries array by extracting the ID, the date, and the entry from the request body and creating a JSON object within curly braces. I'm just going to complete this post request by returning a 200 status with a JSON message of post submitted. And then back in the diary data service, I will submit a new HTTP post request where the expected response is a message of type string. I will also add a second argument after the URI to pass in the diary entry with the request, and this is going to be that JSON data that we extract on the back end. And just as we did with the GET request, we will subscribe to the response, and within that I will call the get diary entries method, and this is going to update the array we have on our static web page within the diary data service. Okay, so with our static website now making a HTTP request to our backend service, and our backend service now responding to that by accepting the request and updating the array, we can restart our backend service and test this. So if I add a new post with the date of the 29th of August and the entry of testing express and hit submit, we can now see it being reflected on the home page, and if I refresh the home page it will still be there. We would like to begin updating and deleting entries. However, to do this we need to identify each diary entry with their ID. So we're currently only using the index that it has within the array. So when we add posts, we would like to ensure that we're adding a unique number to the ID of that post. So I'll need to find the highest ID value that we currently have within our array, then I will simply add 1 to it and give that to the new post. So back in the Express application, I'll add a new get method to return the maximum ID value. I'll create a new endpoint of max-id, and within this method I'll define a new variable, let's just call this max. Then I'm going to loop over all the diary entries we have within our array, and I'm just going to change that max value to the ID of that entry if the entry ID is higher than what we currently have. So overall, this is going to return the highest ID value that we have within the array as a JSON response for the key of max ID. And then back in the diary data service, I'll need to update the ID for each diary entry before we send the post request to the backend server. So for this, I will create a new variable of max ID, and this will be a type number. Then within the onAdd diary entry method, I will make a HTTP GET request to the max ID. And then once we know what the maximum ID is, we can update the diary entry with that new ID, and we're just going to add 1 to it. And once we've updated the diary entry, we can make that post request. So if I just console log our diary entry after we've posted it, and I make a new post on our web page, in the console we can now see that is being updated as ID of 4. So our delete method currently works by sending the index of an entry and calling the splice method on the array of the diary data service. And we're going to change this so it passes the ID value of the entry instead. So in the diary component, I'll change I into diary.id. and this will later be passed to the node server to delete the entry of that ID. And then in the Express middleware, I'll create a new method with app.delete. The URI will be /remove entry, and I'll also add a / with the colon and the ID. So this ID will be used as a parameter within the method when we pick the entry to delete. I can locate the index for our diary entry within the diary entries array by using the findIndex method. This will loop over the elements in the array and will return a value where the element ID is equal to the ID from the parameter. We obtain the ID from the parameter through the request with request.params and then .id. So once we have the index of the entry to delete, we perform a splice on our array, and I will return a JSON message of entry deleted with a 200 success code. So back in the diary data service, I will update the onDeleteEntry method to send a HTTP delete request to the remove entry URI. I will add the ID after the /. We will subscribe to that response and call getDiaryEntries of the diary data service to update the latest entries in the array. So we're forming a bit of a pattern here when we make our requests to the backend server, and we subscribe to it and call getDiaryEntries. I will also update the expected JSON type with a message of type string, and I will also print that to the console. So the final part of our Express enhancement is to update the edit button. So to do this, I'll first update the diary component to pass in the diary ID rather than the index to the edit function. And the call to the edit function will navigate the page to the edit form. So then I will then update the getDiaryEntry method of the diary data service. So first what we're going to do is find the index of the diary entry with the correct ID, and then return that index back to the user. This will ensure we are pre-populating with the correct details as per the ID of the entry and not the index of that entry within the array. So when the form is submitted, the diary form component will usually assign a default value of 1 to the ID of the entry. This is updated when we call onAddDiaryEntry. But when we're in edit mode, I will reassign the ID as equal to the param ID that we have from the URL. As a result, the entry we're submitting will have the same diary ID to be updated, and therefore we're not just reassigning the diary ID whenever we update an entry. Lastly, to complete the update, I will create a new app.put method in the Express middleware. This will have the URI of update entry and will also take a parameter for the ID. In a similar way with the delete operation, I'll find the index by looping through the diary entries, and then I will reassign the diary entries array entry at that position with the new entry within curly braces. And back in the diary data service, I will update the updateEntry method to make a HTTP put request to the updateEntry endpoint, passing in the ID to the URI and the entry within the body of the request, just as we did with a post request. And in a similar way to our other HTTP calls, I will call the getDiaryEntries method to update the diary entries array in the Angular static web page. So that update process was a little bit complicated with quite a few different classes, so let's just walk through it one more time so we can understand how it's working from end to end. So we're sending the diary.id on the edit function, and then in the diary form that is going to be loaded, it's going to be in edit mode. So we extract the ID from the param map, we populate the diary form with the diary using the getDiaryEntry method. The getDiary method will return the diary entry from our array, and lastly, once we submit a new entry, we will ensure the diary ID does not change, and the put method from the node server will update our array in the backend. So that concludes this video, where we have successfully enhanced our application to manage the data in the backend Node Express server. Our diary data service makes HTTP requests for getting all the entries, updating and deleting them, and our Express.js server is responsible for managing the data completely. If I run through the application, we can see that we can now add new entries, delete entries, and also update entries as and when we require. So the final step of our main application is to persist the data from the node server with a MongoDB database. To begin creating our database, we need to sign up to MongoDB online. So head to mongodb.com, where we have the option to try for free at the top right. And this is a free cloud solution that offers us a sandbox of basic features that allow us to test our application. So if you follow the sign up form and the instructions to create an Atlas account, I'll meet you at the next page. So the page that we will be taken to when you sign in will contain our databases with MongoDB. We can build a new cluster within our project, so select Build a Database, then select the free tier options, so I will use AWS in the EU West 1 region, and then at the bottom you can just hit Create Cluster. So clusters host the MongoDB database. These can be horizontally scaled by adding more resources if required, thus the name of cluster. And a cluster consists of a collection of datasets distributed across different servers, and this provides a better read and write performance for us. So the Quick Start menu offers us the option to create a profile for the cluster, and this is what we can authenticate into our cluster with. So I'll just create a username called Aneesh, and the password will be building a mean application. You can use whichever password you like. I just use this one because it'll be easier to reference when we need to in our code. And then you can just hit Create User. We can now use these details to authenticate into our database. So let's just make sure that we save them for later. So as well as creating a user that can authenticate and use our database, we also want to specify which IP addresses can make requests to that database. So for this, we will need to register our IP address into the IP whitelist, then just hit Finish and Close at the bottom. And also make a note that the current IP address that we're using can change. So in the future, if let's say you're accessing your application on different days, you might face connectivity issues, and it might be due to the IP addresses that you have registered as able to access your database. So that's just something to note. So we're able to connect our node application to the MongoDB database by using a third-party package that provides us with out-of-the-box support, and this is called Mongoose. We can install Mongoose into our backend server with npm install --save mongoose. And Mongoose uses schemas to define how our data should look like in a structured way. So this makes it really easy for us to access our MongoDB database with a schema. This way our application knows what the data should be looking like when it goes to access it within MongoDB. So to define a schema, which is how our data will look, I'll create a new file called entry-schema.js, and within this I will first import Mongoose into a constant with the require keyword, and we can now create a schema, which again is the blueprint for how our data should be looking in the database. So I will define a new constant called entry-schema and call the schema method on our Mongoose module. And this method will accept a JSON representation of our data. So I will supply a date and an entry, both of type string, and remember to use capital S for string, as this is not written in TypeScript. We're writing it in JavaScript instead. So I haven't actually included the ID yet. That's because the ID is auto-generated, and we'll see a little bit more detail on how an ID is created and what it means to us in our application just a little bit further in this video. So the next part is defining a model with Mongoose, and a model is going to be used to create items based upon the schema that we have just defined. So we do this with mongoose.model, and within this method we will pass in two arguments. First will be the name of the model, so I'm just going to put diary entry, and the schema that we want to use will be the second argument, so we'll just pass in entry schema. And then lastly, we're going to export this model by doing module.exports equals just before at the start of this line. So we can use our entry model within the Express middleware to persist our data into the database. So first we need to import the model into the Express file with const. I'm just going to call this diary entry model and then equals, and we're just going to point to that entry schema file in the local directory. And the model provides us with the ability to create new instances of the diary entry for the database. Therefore, in the post method, we can do const diary entry equals new diary entry model. And within this method, we're going to be passing in a JSON data representation of our diary entry. So I'm just going to open up some curly braces. I'll do date is equal to the request body date, and the entry is equal to the request body entry, just as we've sort of done before. What I'm going to do next is to console log our diary entry object, and this will just help us to see what it looks like. So one thing we notice is that there is a new field, _ID, that has been created and auto-populated for us as a string. And this _ID represents a unique identifier for each entry that we have within our database, and is very similar to the number we generate and assign to each entry, except all that work is being done by Mongoose. We can now save our diary entry model into the MongoDB database. So the first thing we want to do is to create a connection between our application and the MongoDB database. If we head back into MongoDB cluster, we can connect to our database by first selecting connect, followed by connect your application. And this is going to provide us with a service record address, or SRV, which we can use to connect to our node application. So let's just copy that SRV. And if we go into our Express app, we can first import Mongoose. And what we want to do next is run mongoose.connect. And within the connect method, we're going to paste in that string. So we're going to make two updates to the string. So first, after the .NET /, we're able to specify the name of our database that we're going to create. So the database name I want to call this is just diarydb. And then lastly, what we need to do is paste over the password that we have within angle brackets in the address. So for us, that will be building a mean application. Now our Express app will be able to connect to our MongoDB database for persisting data. The connection will return a promise to us. So what we will do is either console log the success or failure of that connection. So if it does succeed, then I'll just have a then block, and I will console log something along the lines of connected. And if we fail to connect to our database, I'll have a catch block, and I will just console log failed to connect. So a reminder here is that if you see a failure, then the reason it might fail to connect to your database is because in MongoDB, we might not have the IP address that you're using from your computer whitelisted. So you might want to make sure that the IP addresses that you're currently using are accessible to MongoDB. So if we head down to our post method, we will call diaryentry.save. And this diary entry is going to have all the information that we require for saving, such as the exact database connection that is required from our JS file. It will contain the authentication details, it will contain the schema that we're persisting into. So what's going to be persisted is the data that we pass, along with that automated ID that is created. So the diary entry will be persisted into a database with the name of diary entries, as MongoDB will use the name of the model key to create the DB table. So as we define that key as diary entry, it will create a collection called diary entries. So after creating the entry, we will verify this outcome by connecting with the Mongo Shell, which is our only view into the Mongo database as we're using the free tier. So if you're paying for MongoDB, you'll have a nice UI visualization, but otherwise we'll be using the Mongo Shell. So we can download the Mongo Shell into our machine by following the instructions from our MongoDB webpage. Simply select connect as we did before, but then select MongoDB Shell. So into the terminal, we can navigate into the bin folder from our download by calling mongosh, And then what we want to do is copy the string from the MongoDB documents that has been provided to us. And I'm just going to make one small change. So rather than connecting to my first database, what we're going to do is change this name to DiaryDB, as that is the name of the database that we're creating. I'll then enter my password for the database, which is building a mean application, and this will help us to connect. So now let's take a look at some of the commands that we can run for reading our database. So we can run show collections to see the collections that we have within our database, and the collection name, as I mentioned earlier, is the plural of our model name, so that will be diary entries. And then if we run db.diaryentries.find, that is simply like selecting all of the entries from our collection, and we can see all the items printed to us in the terminal. So now we're able to see end-to-end how our application connects with MongoDB and how we're able to actually persist data into MongoDB. So the next step we have here is fetching the data from the database with our application. So if we head to our get method, I'll perform a database search with diaryEntryModel.find. And this method will return all of the entries back to us. Then I will chain this response with .then, which will be executed once all of our data has been returned. I'm just going to pass in that data as the argument, and very simply I will add the response.json method into the then block, passing in that data that we have received from the database to replace the previous diary entries. I'll also add a catch block just for any errors that we're receiving in the data, just to let us know that we're having a problem there. So as we've seen earlier, the response returns us an underscore ID, whereas we have a value of ID in our diary entry model without that underscore. So to help our application match the database, we will transform the response we receive in the diary data service, will be to the diary entries JSON that we receive, and this can now be of type any and not diary entry, because what we receive from MongoDB has the underscore ID, whereas in our diary entry we're expecting that to be ID on its own. So we'll have a problem there if we expect this to be casted to an instance of diary entry. So what I'm going to do is now transform this object of type any into our diary entry, and I'm going to do this by using the pipe method to apply an operator to our response. So I will import the operator from RxJS, and this is called map. And essentially what map does is take all the incoming data, it allows us to then transform it in however way we want, and then we can return that new data to the further part in our pipe. And what we receive is data from MongoDB, and then I'm going to return that same data. We're going to access the diary entries, and we're going to map it. What I'm going to do here is just say what type of data that we're receiving. So we're going to have a JSON data where we have the date as a string, the entry as a string, and an underscore ID object as a string as well. So this is what we expect to receive from MongoDB. And then below that, I'm just going to return a new JSON object where we have the date, which is equal to the entry.date, where we have an entry, which is equal to the entry.entry, and then where we have a new ID, which is equal to the entry.underscore ID, and that's what we're receiving from MongoDB. And then lastly, what I'm going to do is update the subscribe method, which is below this pipe. So we're going to receive the updated data as an argument, just to make it a little bit more reader friendly, and we're going to reassign the value of this.diary entries to the updated data instead of accessing the JSON data that we received before. So if we want to delete a single item, we need to update our Express middleware to use the delete one method. This method will accept an argument that will match a key and value and simply remove that instance from the database. So I'm going to call diaryEntryModel.deleteOne with an open bracket and a curly brace. And within this curly brace, we're going to tell MongoDB, okay, which entry is it that we want to delete and which property is this single entry going to have. So we're going to tell MongoDB, firstly, we want to find the underscore ID property of all the entries that we have within our collection, and the database entry that we will want to remove will have an ID which is equal to the request params and then ID. So it's fairly similar. We're still using the ID to delete an entry, however we're using this delete one method to do so. And I would also encourage you to take a look at some of the documentation from MongoDB so you can have a look at how delete one is working, and also some of the further information that we have on how you can delete items from your database. So before I can pass in the ID as we expect it to be passed in, I'll need to correct our application to read in the ID as a string and not a number. So this is kind of a problem that we have from our earlier videos. Perhaps I should have just defined the ID as a string, but it's not too complicated of an update to make, and it just allows us to also work through our application one more time so we can see how everything is working. So for now, I will change the diary entry model to replace the ID as a string, and then there's also some other references within our application. So I'll head to the diary component and also the diary form. So now when we select delete, we will be passing in the ID, which is a string, which comes from MongoDB, to the Express middleware. And then the diary entry model will call delete1, passing in the JSON of _ID and the ID we have from our entry. So the final update for us to make is for editing the diary entry. And at the moment, our application will mostly work with loading the diary entry into the form. This is because the pre-existing code that we had in the diary form component is still relevant. It will still check for the edit mode. It will still pass in the param ID, which is now that long string, to the diary data service to get the diary entry method that we want. And then this method will return the index of the diary entry with the correct ID. So it's still sort of working in that sense. However, we still have work to do to update the single entry in MongoDB for this to work as we would like it to. So if we head to the put method in our Express file, we will define a new constant called updated entry using the diary entry model. This will use the JSON data that we've already defined from our request body. However, we will just need to change the ID to _ID and to create a new instance of our diary entry model within brackets. Now we have our updated entry, we will be able to use the update1 method from our diary entry model, and again this has been taken from the MongoDB documentation, and this will specify which entry in our database to update. So we're going to pass in two arguments here. So first we want to tell MongoDB which item is it that we're going to be updating, and we're going to have an identifier for this. So within curly braces, I'll pass in the key of _ID. So it's going to be looking for the _ID property and the value of the request params ID. So now MongoDB knows, okay, we're looking for the ID of this value to be updated. And what are we going to be updating it with? So we're just going to be passing in the updated entry object as the second argument. So now MongoDB knows what to update it with. I'm just going to close off this request with a then block, where the response of status 200 and a JSON response message is going to be returned just as we had before. So let's head back into our application to see it working. And that's it. Our entire full stack mean application is now working. Let's do some cleaning up in our code for redundant methods such as the diary entries array in the Express file and the maxID method and the maxID HTTP call made in the diary data service. And that's actually it. So thank you so much for watching through the series, and well done on creating a complete application with MongoDB, Angular, Express and Node. There is still a lot of work that this application can do from handling exceptions, adding meaningful error responses, and so much more. There's so much great documentation with MongoDB that I would encourage you to check out, but I am also going to publish some future videos on how you can do all of this.